Hello class, this is a continuation of the proofs for extension identities. In the previous video we saw how we could use the unit circle to prove the difference of angles for cosine. We're now going to use this one identity to prove all the others. So let's get moving. The sum of angles for cosine. So we're going to prove cos of a plus b equals cos a cos b minus sine a sine b. For this, we're going to use the difference of cosine. And from here, we're going to let b become negative b. So b becomes negative b, b becomes negative b, b becomes negative b. From here, we hope you can see that this is pretty simple. That's a minus b. That becomes a plus b. Now here's where it gets a little bit tricky. Cos of negative b. Using the identity of cos negative theta is equal to cos theta. Just quickly going over that. Here's cos theta. Cos of negative theta is the same angle, just going backwards. But if it's the same angle going backwards, that is in the fourth quadrant. Cosine in the fourth quadrant is positive. So this negative angle going backwards is the exact same as cos of, it's the exact same if cos theta were positive. Because, once again, going backwards this way is the same triangle, is the same triangle drawn as if it were in the positive side, because cos is positive in the fourth quadrant. So cos of negative b is the same as cos b. Sine of negative b, so using the same logic, negative b, so if this is sine b, sine here would be positive. If we were to draw this same triangle in the fourth quadrant, going downwards like this, it's as if it were the same triangle in the first quadrant, except now, since sine is in the fourth quadrant, it is negative. Hence why sine of negative theta is negative sine theta. So sine of negative b is negative sine b. So just by a simple substitution of b equaling negative b, we can get this proof. So let's move on to sine. The sum of angles for sine. For this, we're going to use the difference of cosine once again, the very first one in the previous video. And now we're going to let a equal 90 minus a. So taking a look, a becomes 90 minus a becomes 90 minus a becomes 90 minus a. From here, I can factor out negative 1, so negative outside of a plus b, and this will remain the same. Now, the complementary identities are as follows. Sine theta is equal to cos of 90 minus theta. So, cos of 90 minus theta is sine theta. So this expression becomes sine of a. Likewise, sine of 90 minus theta is cos theta. So this expression becomes cos a, because it's sine 90 minus a. So the right hand side is this expression. As for the left hand side, this one gets a little bit tricky. This is 90 minus theta. Using this same identity here, take a look. 90 minus theta, 90 minus theta is sine theta. But in this case, theta is the entire expression of a plus b. So cos of 90 minus a plus b is sine a plus b. the difference of angles for sine. So using the sum of two angles for sine, we just let b equal negative b. So taking a look, b becomes minus b, b becomes minus b, b becomes minus b. In the exact same way that we use the fourth quadrant idea, cos of negative theta is the same as cos theta. So cos negative b is cos b. Sine of negative theta is negative sine theta. Hence why sine of negative b is negative sine b. So sine of a minus b is this expression here, based off the previous identity shown here. Now for the sum of angles for tangent, or tan, we're going to use the tan identity. Tan theta is sine theta over cos theta. So if we have tan a plus b, we get sine a plus b over cos a plus b. Using the previous identities, this expands, and this expands to the denominator. So sine a plus b becomes this, cos a plus b becomes this, using the previous identities shown. Now here's where it gets a little bit tricky. It's very unclear that we ought to do this, but if we divide each and every term by cos a, cos b, we get the following. Taking a close look, so dividing this, dividing this, dividing this, and I think you get the idea. We're going to divide each term by cos a, cos b. Zooming in very carefully, cos b cancel, leaving us with sine a, cos a. Cos a cancel, leaving us with sine b, cos b. On the denominator, that's cos a, cos b divided by itself, we get 1. Sine a, cos a divided, we get tan. Sine b, cos b, we get tan b. Since we're left with just sine a, cos a, cos b, sine b over cos b, we're left with the identity we are looking for. As for the difference of angles for tan, we're going to use the exact same idea. We're going to use this and substitute tan a minus b becomes sine a minus b divided by cos of a minus b. And since we already have the identities for the difference of sine and cos, we can do the exact same proof to conclude to what we need here. So, in summary, the sum or difference trig identities are as follows. These 3 here, but really there's 6 because there's plus and minus for each. But I need to draw your attention very closely to cos. If it's plus or minus, it becomes minus or plus, meaning if it's cos a plus b, it becomes cos a cos b minus sine a sine b. But if it was cos of a minus b, it becomes that plus instead. Likewise with tan, if it's a plus b, the denominator becomes a minus. And if in tan it's a minus, the difference of a minus b, it becomes a plus in the denominator. Now very quickly, since we're nearly there, to prove the double angle identities, sine 2a becomes 2 sine a cos a, cos 2a becomes cos squared a minus sine squared a, and tan 2a equaling 2 tan a minus divided by 1 minus tan squared a. To prove these, we take any of the sum identities and let b equal a. So take, for example, here is the identity for the sum of sine. letting b equal a, we get sine a plus a. And likewise, substituting this for a, substituting this for a, we get sine a cos a. And now, even though this looks backwards, it's multiplication, it's sine a cos a. So these are like terms, hence we get 2 sine a cos a. You could do the exact same idea of using this, so cos of a plus b, or tan a plus b, and let b equal a to find the proof for each of these. So I hope that gave you an insight to all the proofs for the sum or difference identities and the double angle identities as well. Hope to see you in the next video. Best of luck.